Hello everyone, I am Dr. Raman. In this session, we are going to discuss with Fourier transform entire unit formulas. Fourier transform use the notation f of s or f of small f of x. Fourier transform of function of x is equal to 1 by square root of 2 pi integration of minus infinity to plus infinity f of x e power isx into dx. Inverse Fourier transform f of x equal to 1 by square root of 2 pi integration of minus infinity to plus infinity Fourier transform of s e power minus isx into ds. Parseval's identity Fourier transform integration of minus infinity to plus infinity f of x square dx is equal to integration of minus infinity to plus infinity Fourier transform of s square ds. Fourier cosine transform. Fourier cosine transform, we use the notation fc of s or fc of f of x is equal to square root of 2 by pi integration of 0 to infinity f of x cos sx into dx. And inverse Fourier cosine transform, f of x is equal to square root of 2 by pi integration of 0 to infinity the Fourier cosine transform of s cos sx into ds. Parseval identity Fourier cosine transform integration of 0 to infinity f of x square dx is equal to integration of 0 to infinity Fourier cosine transform of s square ds. And Fourier sine transform, Fourier sine transform f of s and fs of f of x is equal to square root of 2 by pi integration of 0 to infinity f of x sin sx into dx. Inverse Fourier sine transform f of x is equal to square root of 2 by pi integration of 0 to infinity Fourier sine transform of s sin sx into ds. Parseval identity Fourier sine transform integration of 0 to infinity f of x square dx is equal to integration of 0 to infinity Fourier sine transform of s square ds. So these are the formulas for Fourier transform, Fourier cosine transform, Fourier sine transform. Next, properties of Fourier transform, properties of Fourier cosine transform, and properties of Fourier sine transform. First of all, properties of Fourier transform. The first property, linearity property. The Fourier transform of a function of x, plus b, g of x is nothing but we should write the form of a into f of s and plus b into g of s. The f of s is nothing but Fourier transform of f of x. The next property, shifting property in x. So Fourier transform f of x minus a is equal to e power ias and Fourier transform of s. Next property, shifting property in s. So Fourier transform of e power iax is equal to e power iax into f of x is equal to the Fourier transform of s plus a. The next property, change of scale property, f of Fourier transform f of ax is equal to 1 by a Fourier transform of s by a. Then next Fourier transform property, modulation theorem. Fourier transform f of x cos ax is equal to 1 by 2 Fourier transform of s minus a plus Fourier transform of s plus a. And then next property, derivative. Fourier transform of x power n f of x is equal to minus I power n d power n by ds power n Fourier transform of s. The next derivative property, the Fourier transform f dash of x dash is nothing but derivative is equal to minus is into Fourier transform of s. Then another properties of Fourier transform, integration. So Fourier transform of integration of ax f of x is nothing but I by s into Fourier transform of s. And next property, Fourier transform of f of x bar is equal to Fourier transform of minus s bar, where here bar is denote the complex conjugate form. Next property, Fourier transform f of minus x bar is equal to Fourier transform of minus s bar. The next properties of Fourier cosine transform. The first property, linearity property. So Fourier cosine transform of a f of x plus b g of x is nothing but a Fourier cosine transform of f of x plus b Fourier cosine transform of g of x. So next property, Fourier cosine transform of f of x cos ax is equal to 1 by 2 Fourier cosine transform of s plus a plus Fourier cosine transform of s minus a. Then next property, Fourier cosine transform of f of x sin ax is equal to 1 by 2 Fourier sine transform of a plus s plus Fourier sine transform of a minus s. Then next property, Fourier cosine transform of f of ax is equal to 1 by a Fourier cosine transform of s by a. And then Fourier cosine transform of f dash of x is equal to minus square root of 2 by pi f of 0 plus s into Fourier sine transform of s. And then next property, Fourier cosine transform of x f of x is equal to d by ds, the Fourier sine transform of s. Then next properties of Fourier sine transform. First property, linearity property. Fourier sine transform of a f of x plus b g of x is nothing but a into Fourier sine transform of f of x plus b into Fourier sine transform of g of x. The next property, its name of modulation property. Fourier sine transform of f of x cos ax is equal to 1 by 2 Fourier sine transform of s plus a plus Fourier sine transform of s minus a. The next property, Fourier sine transform of f of sin ax f of x sin ax is equal to 1 by 2 Fourier cosine transform of s minus a minus Fourier cosine transform of s plus a. The next property, Fourier sine transform. Fourier sine transform of f of ax is equal to 1 by a Fourier sine transform of s by a. The next property of Fourier sine transform. Fourier sine transform f dash of x is equal to minus s Fourier cosine transform of s. And then next property, Fourier sine transform of x into f of x is equal to minus d by ds, then Fourier cosine transform of s. And then next, convolution theorem. So the convolution theorem is nothing but Fourier transform of f of x star g of x. Here we used star. The star is nothing but is not a product symbol. It's a star convolution theorem symbol. Star is a convolution theorem symbol. Therefore, the Fourier transform of f of x star g of x is equal to Fourier transform of f of x and Fourier transform of g of x. So Fourier transform f of x, we write the short form of f of s, and Fourier transform g of x is g of s. Then f of x star g of x is nothing but f of x star g of x is equal to 1 divided by square root of 2 pi integration of minus infinity to plus infinity f of t g of x minus t into dt. So these are the formulas for Fourier transform entire unit. Thank you.